Solving 10a, we're solving linear equations with distributing. So here are the examples. Take a screenshot and then follow along with me. Number 1, 5x plus 10 equals 15. I want to solve for x. I have a 5 attached by multiplication and a 10 attached by addition. And of course, when we're solving, we undo PEMDAS. We undo when we're solving. To undo subtraction, we add. To undo addition, we subtract. To undo division, we multiply. To undo multiplication, we divide. These are all partners and they undo each other. So first I'm going to take this 10, which is attached by addition, move it by subtraction to the other side of the equal sign. And I just keep my eye on the prize. I want to get the x alone. 5 is attached by multiplication, move it by division to the other side of the equal sign. My x is alone, so I have solved. But now I'm going to do the arithmetic. Do the top first because it's a package. 15 minus 10 is 5. 5 divided by 5 is 1. Number 2, 5 times the package x plus 2 equals 15. Now this is called distributing. And what distributing is it's saying I have 5 of these packages. So I could add them 5 times. 1, 2, 3, 4, 5 x's plus 2, 4, 6, 8, 10. I could do it that way. Or I could just distribute, and that would be going like this. 5 times x plus 2. I have 5 x's, and I have 5 positive 2's. 5 times 2 is 10. That's what distributing is, and I do a lot of lessons in the distributing unit. So if this seems a little confusing to you, go back and review that. Meanwhile, I'm going to solve this. So I'm going to distribute. 5 times x is 5x plus 5 times 2 is 10 equals 15. If this looks suspiciously like number 1, it's because it is. Okay, I want to get the x alone. 5 is attached by multiplication, 10 is attached by addition. I move the addition first to the other side by subtraction. Now I still want to get the x alone. 5 is attached by multiplication, move it by division to the other side of the equal sign. And I have 15 minus 10 is 5. 5 divided by 5 is 1. Number 3, 6 times the package x plus 3 equals 72. I can't get into this x because it's in a package, and so first I have to distribute. 6 times x is 6x plus 6 times 3 is 18 equals 72. Now it looks just like one of our linear problems. First, we're going to undo our addition by subtraction to the other side of the equal sign. Now I want to get the x alone. 6 is attached by multiplication, move it by division. My x is alone, so I'm happy. Now I just have to do this math. 72 minus 18. And remember, the top is considered to be a package. That's why we do that before we do any division. I have to borrow here. 12 minus 8 is 4. This left us 6. 6 minus 1 is 5. I have 54 divided by 6, which is 9. Number 4, 3 times x minus 5 equals 45. So I have 3 of these packages I have to distribute. 3x minus 3 times 5 is 15 equals 45. I want to get the x alone. First I undo the subtraction by adding to the other side of the equal sign. Now this 3 is attached by multiplication, move it by division to the other side of the equal sign. And I'm getting x equals, let's see, 45 plus 15 is 60. 60 divided by 3 is 20. Number 5, 118 equals 11 times the package x plus 3. And I see that I have 11 of these packages, so I'm not going to write out x plus 3 11 times and add it. I'm just going to multiply. So I have 11 x's plus 11 times 3 is 33. Write my equal sign, try to line things up. My x is over here. I want to get it alone. It doesn't matter which side of the equal sign it's on. I just want to get it alone. First, I'm going to move this 33 by subtraction. I didn't leave a lot of room, so it's going up there. Now this 11 is attached to x by multiplication. I'll move it by division to the other side of the equal sign. And let's see what I have here. I have 118 minus 33. 8 minus 3 is 5. 1 minus 3, I can't do that. So I'm going to borrow a 1 here. It leaves 0 here. 11 minus 3 is 8. I have 85 over 11. And I'm going to leave it in that form. Number 6, 15 times the package x plus 3 equals 75. I'm going to distribute the 15 through each term in the package. And I haven't told you up to this point, but inside this package here are two terms, term 1 and term 2. And terms are separated by plus, minus, or equal signs. And we'll talk about that more when we need to. Meanwhile, 15 times x is 15x, plus 15 times 3 is 45, equals 75. Okay, looks like my standard linear equation. I want to get x alone. 45 is attached by addition, move it by subtraction to the other side of the equal sign. Now I want to get the x alone. 15 is attached by multiplication, move it by division to the other side of the equal sign. Now my x is alone, and I have to clean it up. 75 minus 45. 5 minus 5 is 0. 7 minus 4 is 3. So this is 30 over 15 is 2. Number 7, 20 times 6 minus 2x equals 40. I have 20 of these packages, so I'm going to multiply 20 to each term inside the package. 20 times 6 is 120, minus 20 times 2x is, I put the minus first because I always do sign first. 20 times 2 is 40, x equals 40. I want to get x alone. I have 120, and this is actually attached by addition. And I have this minus 40x. And remember, we prefer this to be positive if we can. So I'm actually going to add the 40x over here first so that I can get it positive. Now I'm going to get the x alone. This 40 is attached by addition. I'll move it by subtraction to the other side of the equal sign. Okay, so now I have 120 minus 40 is 80 equals 40x. I want to get that x alone. 40 is attached by multiplication, move it by division to the other side of the equal sign, and I'm getting x equals 2. You might say, why didn't I move the 40 before I minused it and made it 80? And remember, I could have just brought it over here at that point, and I would have had the same thing. It was getting sloppy though, so I wanted to clean it up. Number 8, 72 equals 18 times the package 3x plus 4. I have to multiply the 18 to the first term and the second. I'm going to write it out like this. 3 times 8 is 24, carry the 2. 3 times 1 is 3, plus 2 is 5. So I have 72 equals 54 x's plus, now I have to do 4 times 18. 4 times 8 is 32, carry the 3. 4 times 1 is 4. 5, 6, 7. Now I have 72. I want to get the x alone. I have something attached by addition and something attached by multiplication. First, we undo addition. We minus it over to the other side. Keep your eye on the prize. This 54 is attached to the x by multiplication. Move it by division to the other side of the equal sign. We have x equals 72 minus 72 is 0 over 54, which is simply 0. Number 9, 14 times x plus 1 equals 14. I'm going to distribute the 14 to each term in this package. I get 14x plus 14 times 1 is 14 equals 14. Keep your eye on the prize, which is the x. I want to get it alone. I'll move the 14 attached by addition by subtraction to the other side of the equal sign. Now get the x alone. 14 here is attached by multiplication. Move it by division to the other side of the equal sign. I'm getting x equals 14 minus 14 is 0. 0 divided by 14 is 0. Number 10, 7 times x minus 3 equals 0. I'm going to distribute the 7 through to each term in the package. 7 times x is 7x. Carry my sign. 7 times 3 is 21 equals 0. I want to get the x alone. First, I'll add the 21 to the other side of the equal sign. Now, the 7 here is attached to the x by multiplication. Move it by division to the other side of the equal sign. Getting x equals 0 plus 21 is simply 21. Over 7 is 3. Solving 10A, linear solving with distributing, these are the try-its. So you've watched the examples, take a screenshot and try them along with me. Pause each one and try it on your own, then watch me do it. Let's get started. Number 1, 5x minus 15 equals 25. So when we solve, we undo PEMDAS. We undo PEMDAS when we solve. So first we're going to undo this subtraction by addition to the other side of the equal sign. Then we're going to undo this multiplication by its partner, division, to the other side of the equal sign. And I'm done. X equals 25 plus 15 is 40 over 5 is 8. I say I'm done because once the x is alone, that was all I wanted. I wanted to solve. This is just reducing the arithmetic. Number 2. 5 times the package x minus 3 equals 25. So I have 5 of these x minus 3 packages. So I could just add them up. 1, 2, 3, 4, 5 x's. These are all minus, so I'm going to write my sign. 3, 6, 9, 12, 15. I could do that. But I want to show you how to multiply. And what you do is this multiplication goes to each term in a package, and a term is separated by a plus or a minus or an equal sign. 5 times x is 5x minus 5 times 3 is 15 equals 25. You see I got the same thing here as here. This is a bit faster though. Now I want to get the x alone. 15 is attached by subtraction, move it by addition to the other side of the equal sign. And this is the same as problem 1 now, isn't it? After we've distributed, it is the same problem. I want to get the x alone. 5 is attached by multiplication, move it by division to the other side of the equal sign. 25 plus 15, we had 40 over 5, which is equal to 8. Number 3, 18 times the package x minus 3 equals 36. I want to solve for x. And I'm going to distribute the 18 to each term in the package. 18x minus 18 times 3. 3 times 8 is 24, carry the 2. 3 times 1 is 3, 4, 5. Minus 54 equals 36. So let's keep our eye on the prize. I'm going to move this a little. I want to get x alone. 18 is attached by multiplication. 54 is attached by subtraction. I undo subtraction first, and I add it to the other side of the equal sign. This 18 is attached by multiplication. I move it by division to the other side of the equal sign, and I'm getting x equals 36 plus 54. 6 plus 4 is 10, carry the 1, 5, 6, 7, 8, 9. I have 90. 90 over 18. Now, watch fractions if you want to understand what I'm doing here, but I'm going to show you how to reduce fast. 90, I'm going to make 9 times 10. 18, I'm going to make 9 times 2. And I know that 9 over 9 is 1. So this 9 and this 9 go away and just leave 1. And then 10 divided by 2 is 5. Number 4. 100 equals 50 times x plus 1. So I have to distribute the 50 to every term in this package. 50 times x is 50x plus 50 times 1 is 50, and that equals 100. I want to get x alone. This 50 is attached by addition. This 50 is attached by multiplication. First, I undo addition and I subtract it to the other side of my equal sign. Now I want to get this x alone. The 50 is attached by multiplication. I'll move it by division. This is getting ugly. To the other side of the equal sign. Sometimes I let it get ugly because I want to keep on just taking things away from my x. And I don't want to worry about doing the arithmetic. I'll do that when I'm all done. And everything is already set up in PEMDAS form when I move things in this manner. 100 minus 50 is 50. 50 over 50 is 1. When you solve like this, everything is set up in correct PEMDAS order to just reduce your arithmetic quickly. Number 5, 144 equals 12 times the package 15 minus 2x. Okay, I'm going to distribute the 12 to each term. And remember, terms are separated by plus, minus, or equal signs. This is one term here, okay? So I'm going to write my 144, and I'm going to go 12 times 15. I have to write that out. 5 times 2 is 10, carry the 1. 5 times 1 is 5, plus 1 is 6. Put a 0 here as my placeholder because I'm moving over. 1 times 2 is 2. 1 times 1 is 1. Now I add 0 plus 0 is 0. 6 plus 2 is 8, and 1. So I'm getting 180 minus 2 times 12 is 24 x's. Now, I don't like my x's to be minus. I like them to be added. And that's going to be lesson 11, which is right after this. But I'm going to move this over here because I want it to be positive. Okay. Now that my x's are positive, I just want to get the x alone. I have 24 attached by multiplication, 144 attached by addition. I'll move the 144 by subtraction first. Now I'm going to get the x alone. The 24 is attached by multiplication, move it by division to the other side of the equal sign. Now I have to do this arithmetic. I have 180 minus 144. I'm going to borrow here. 10 minus 4 is 6. I was left with a 7. 7 minus 4 is 3. 1 minus 1 is 0. So what I have here is 36 over 24. And I'm going to reduce this again for you because I want you to get used to this reducing. So 36, I'm going to make 9 times 4. That's what jumped into my head. I'm going to make 24 6 times 4. You might have said, can you make it 8 times 3? And I could, but I'm looking for things that will reduce out. So this 4 over 4 goes away. I'm not done. I have 9 over 6. How about we take the 9 and I'm going to rewrite it so that it's not getting so sloppy. I'm going to take that 9 and write it as 3 times 3. I'm going to take the 6 and write it as 3 times 2. Reduce again, and we get x equals 3 halves. Number 6, 25 times the package x minus 2 equals 5. I'm going to distribute the 25 through. 25 times x is 25 x's minus 25 times 2 is 50 equals 5. Okay, get the x alone. 50 is attached by subtraction, move it by addition to the other side of the equal sign. 25 is attached to x by multiplication, move it by division to the other side of the equal sign. X equals 50 plus 5 is 55 over 25. I'll reduce this a little bit. 55 is equal to 5 times 11. 25 is equal to 5 times 5. 5 over 5 reduces to 1, and I get 11/5. If this reducing is a little confusing, go to my Lynn desk piece, fractions, and check it out. Number 7. 24 equals 4 times 5 plus 2x. So I'm going to distribute right away. 4 times 5 is 20, plus 4 times 2x is 8x. My x's are positive, so I'm pretty happy, so I'm going to choose to keep my x's on this side of the equal sign and just get it alone. 20 is attached by addition, move it by subtraction to the other side of the equal sign. You might say, how can you tell it's attached by addition? Because in front, if there's no subtraction symbol, then it's addition, unless it's multiplied. So if it's just sitting there, it's being added. Now I want to get this 8 away from the x. It's attached by multiplication. Move it by division to the other side of the equal sign. 24 minus 20 is 4 over 8. And this reduces to, this will give me 4 times 2. 4 and 4 goes away, leaves a 1. So I'm getting 1/2 equals x. Number 8, 130 times x plus 2 equals 260. I am not going to write out the package x plus 2 130 times. I'm going to distribute. 130 times x is 130 x's plus 2 times 130 is 260 equals 260. My x is positive, so I know I don't have to move this term. I just have to get the x alone. First, I'll take this 260 and subtract it over to the other side of the equal sign, and it's gone. Now this 130 is attached by multiplication. Move it by division to the other side of the equal sign. My x is alone. Now I'll reduce. 260 minus 260 is 0. 0 divided by anything in the whole wide world is still 0. Number 9, 6 times the package x plus 1 equals 6. I am going to distribute the 6 through the package. 6x plus 6 equals 6. Wow, a lot of 6's in this problem, but keep your eye on the prize. You want to get the x alone. This 6 is attached by addition. Move it by subtraction to the other side of the equal sign. And now this 6 is attached to the x by multiplication. Move it by division, its undoing partner, to the other side of the equal sign, and I'm done. My x is alone. I'll clean this up. 6 minus 6 is 0. 0 over 6 is still 0. Number 10, 9 times x minus 2 equals 0. I am going to distribute the 9 through the package because I want to solve for x. 9x minus 18 equals 0. Notice when I distribute, the parentheses go away. Keep your eye on the prize, get the x alone. 18 is attached by subtraction, move it by addition. To the other side of the equal sign, the x is almost alone. The 9 is attached by multiplication, move it by division. To the other side of the equal sign, and I'm done. I'll clean it up. I have 18 over 9 equals 2. All done.